Okay, so we're going to go through this process. I'm going to show you start to finish, and then you need to practice this until you can repeat it and get things right every single time. There's a few steps to it, but if you have this video, you might have to refer to it a little bit as you go, but eventually, if you do enough of them, you'll have it down just fine. So our first step, I think, is to find these components to these. Now, when we find the components of vectors, remember we're going to use the cosine of the angle times the magnitude to get the x component. So for example, our goal here is for vector 1 is to find its x component and its y component. And for vector 2 to do the same thing. Now to do that, you don't necessarily have to write out what I'm going to write out. In fact, as you go through, you probably won't write it all out. But to show you what I'm doing, I'm going to need to do that. So for example, if I want the V1's x component, I'm going to take the magnitude, 220, times the cosine, x goes with cosine, right? X cosine of 132. Now, I would suggest on that since it doesn't matter if we take 220 times the cosine of that or the cosine of that times 220, right? 5 times 3 is the same as 3 times 5. Let's do this part first, actually. Let's go ahead and type in 132 on this calculator and hit cosine. Wait for it. There's the cosine times, whoops, that went away. Let's try that again. 132 cosine times 220. And that gives me an x component of negative 147.2. So negative 147.2, we'll say. That's the x component of this vector. Now we'll do the y component of that vector. Well, that's going to be v1y is going to be 220 times the sine of 132. So I'll do 132, find the sine, times 220, and I'll get 163.5. So the y component is a positive 163.5. Notice I put the positive in there. If it had come out negative, I'd put a negative there. Alright, to do the same for V2, we're going to take 350, so you can pause the video, by the way, and try it on your own real quick and see if you get what I get. So I'm going to do 350 cosine times 300, the magnitude. And for that I get 295.4 positive. And for the y component, I'm going to do 350 sine times 300. And that's going to be negative 52.1. So you can do that once you get comfortable with it. You really don't need to write all this out in order to do it. You can just know how to do it and punch it out and get the numbers there. I'm going to erase these because it's going to make my presentation of this whole thing better. So you can even do that off to the side. Alright, so I recommend setting it up this way, in fact doing it this way every time, and in fact let's take a moment and let's look at graphing these to help us out a little bit. So a couple different ways to look at this. Let's see, so I need 220 and 300, I only have these blocks, so let's say I go 50 of these per block. So this, for example, will be 50, 100, 200, 250, and so on. So 220 at 132 degrees. Well, 132 degrees is probably somewhere in here, in that neighborhood. Now I can use the components to find that even more easily. For example, this is approximately negative 150. So it'd be 50, 100, this would be negative 150. And this is approximately positive 150. 2, 3, maybe a little more, so it's like in there. So that, I like using the components when I can, because it's easier than getting a protractor out and measuring the angle. That is vector 1. And what about vector 2? Well, 300 degrees would be down in here somewhere. Almost the exact opposite, isn't it? Let's hope not. Let's hope it's not exactly opposite, because I'm going to be a little ugly, but that's all right. We'll figure it out. So is going to be, let's see, positive 295, so almost 300. So 1, 2, 300, and then negative 50. So it's right about in here. No, it's down in here. 350 degrees. Sorry, not 300 degrees. 350. That's why. Okay, we're good. And this is vector 2. So when we add them, what will we expect to get? Well, we can go, if we like, well, let's sketch the parallelogram. So this would be down, like, say, here, parallel to that side. And then over here, I'm going to sketch a line that's parallel to this one. And wherever they meet is approximately where I would expect V1 plus V2 to be. And of course, the other direction, same length, it would be where the opposite of V1 plus V2 is. So I would expect something in the first quadrant here for my answer. Let's find out. So mathematically, all we have to do is add the x components to each other and add the y's. So V1 plus V2, that vector is going to be whatever I get when I add the, when I say add, of course, they're different signs, right? One's negative, one's positive. So I'm going to combine those. So I'm going to go 147.2 negative plus 295.4. That's going to give me a positive 148.2. That's my x component. And then for my y, I'm going to do 163.5, but that's going to be, yeah, it's positive, minus, I'll do it that way, 52.1. That's going to get me a positive 111.4 is my y component. Let's see if that makes sense on my drawing. 148, that's about 150. So 50, 100, 150 up, and then about 100. So it's really more like in here. My parallelogram was maybe not quite good enough, but that's okay. This up here, I think, probably should come down more. But it's off in that direction. Still in the first quadrant, so I'm feeling pretty good about that. What would the opposite of V1 plus V2 be? Well, the easiest way to get the opposite is to just switch the signs on the components for the V1 and V2. So instead of positive, positive, it's going to be negative 148.2. And it's going to be negative 111.4. Let's figure out this vector, which would be down in here somewhere. Let's figure out that vector in angle magnitude form. In fact, we'll figure them both out. But let's start with this one. So we're going to find this, let me find it, there you go, the opposite of their sum in magnitude angle form. So let's go through that process. First, we're going to find the magnitude of that vector. So we're going to find, the way we would write that is with an absolute value. So we want the magnitude of that vector, just the length. So you can ignore the negative signs for this. We're just going to do the square root, basically the Pythagorean theorem, of 148.2 squared plus 111.4 squared. The x and y component squared and then added together. Ignore the negative signs. So it's going to be 111.4 squared plus 148.2 squared equals. Then I'm going to take, I'll write it out. So it's 34373.2 magnitude of the opposite of V1 plus V2. Then we're going to take the square root, this button right here, and it's 185.4. So the magnitude of that vector, that's what these absolute value means, the magnitude, is 185.4. So I can fill that in down here, 185.4. Now I need an angle. So the way we do that is we find the reference angle by taking the inverse tangent of the y over the x, right? The y component over the x. Once again, ignoring negative signs. So reference angle is the inverse tangent of the y, which is 111.4, over the x, which is 148.2. So put that here. So let's go 111.4 divided by 148.2, get an answer. Then I'm going to do second. So the inverse tangent is going to be second tangent. And that's going to be 36.9 degrees is my reference angle. Now, 36.9 degrees. But that's the reference angle. Remember, we're talking about this opposite vector, the one that is down here in this location. What angle did we just find? This 36.9 is this angle right here. So I can write, if I want, I can go down to my answer here and I can write this angle in a couple of different ways. I can write 36.9 and then indicate that we are in the third quadrant. Or I can take, and this you have to get from looking at the graph, but I can go to get the actual angle from here all the way around to there would be 90 plus, so it would be 180 plus the 36.9. So I could just add 180 to that. So it's 216.9. Another way to write that answer then would be 185.4 at 216.9 degrees. Now, you could go through that whole process again for the original, the sum of the vectors, but I got a quicker way to do it. They're opposites of each other. So the other one is going to be 180 degrees opposed. In other words, I can take this angle and subtract 180 from it, and I'll be in good shape. So it should be 185.4. The magnitude won't change. Those numbers are still the same. We ignore the negatives. And the angle is going to be 216.8 minus 180, 180 degrees in the other direction. That's actually 36.9, of course. But that's this angle here for that one. So we're talking about this vector. This vector, the sum of the two, which would be in this region. The opposite of the sum is down here. And so here are our two answers. There is no other way to write this, because if you write 36.9, you don't write anything else. It's assumed that it is in the first quadrant, which is right here. All right. Hopefully this helps. You're just going to need to repeat it again and again until you're comfortable with it. I will give you this little hint as you go through. So when you're trying to find those angles, you can always find the reference angle, right? Well, in the first quadrant, the angle you want is the reference angle. Whatever you find, it is, it is. There you go. In the second quadrant, the angle you want will be 180 minus the reference angle. In the third quadrant, the angle you want, and this is like the one we had here, is going to be 180 plus the reference angle. Remember, we did 36.9 plus 180, and that gave us the actual angle. And in the fourth quadrant, the angle is going to be 360, right? 360 minus the reference angle. So that's a little cheat sheet for you when you want to find the actual angle and not the reference. Now, notice I know that this one, for example, is in the third quadrant by looking right here. Take a look. You see that negative sign for x, and the y is negative as well. Third quadrant is where x and y are both negative. All right, we'll leave it at that. Try the other problems that are attached to this, and I'll prove somewhere in there should be the answers to all of them, so you can find out if you're doing it right. You zoom this out a little bit, and you can take a look at everything if you'd like, all at once in all of its glory. Maybe. Almost. We got this. Not bad. There we go. And there's all of it, all in one shot. All right, good luck.